Hello and good morning here from Studio C from QtDevCon 2020. This is the first talk of this series here in this room, and it will be held by Tomasz Pawłowski. And the talk will be about crowdsourced quality assurance. I asked myself, well, if you don't do quality assurance at all and give it to your customer, isn't that also crowdsourced quality assurance? But I'm sure you're going to disagree on that, and you're going to tell us what you really mean by this. And I think Tomasz is trying to combine that with code coverage and see how it's maybe possible to join both of those worlds. And I wish you lots of fun with this talk.
So, welcome everyone. So, I'm Tomasz Pawłowski. I joined Froglogic 8 years ago, which was the original vendors of some QA tools, like for automated GUI testing, for code coverage, and for managing test results. Last year we were acquired, and now we are the part of the bigger Qt company family. A short story about this talk. It was actually not my idea. It was my colleague who submitted this talk, and then he left the company. So here I am, I hope I managed to lower some expectations. Right, and also make not sure if a smart decision to do some live demos. So let's see how it will go in the end. Okay, so first I will talk a bit about crowdsourced software testing, then a bit about code coverage using our tool Squish Coco, and then we'll think about how we can marry those two things, which for most people you might think should never be connected, but we'll see if that is possible. So what is crowdsourced software testing? So now when if you want to buy a car, everybody is saying to you, why to buy a car if you can rent a car for a minute? And the same way applies to crowdsourced software testing, why you can hire and maintain a QA in-house team, which is very expensive. They want free lunch, they want vacations, they want to leave the job at 5 p.m. So it's a nightmare. So then there is a crowdsourced software testing that can help with that. So basically, we'll be sending out our software prototype of the software and products to the tester experts instead of testing that software internally. You may heard alternative names for that, like crowd testing, network testing. So, and the idea is to be faster, to deliver our software faster to the market. If we can very quickly, in the terms of days, give our software to the huge number of testers, we do it very quickly, and we can have very short testing phase. And all of that is organized on some dedicated platforms. So basically, if you search for crowdsourced software testing, a lot of companies that they praise that they have the best testers possible, and that they will do all the testing. And you use this platform from this company, and you are basically paying the companies by hour or by the number of bugs found. And of course, those platforms really promise that they will work 24 hours, 7 days per week, and they have the best testers. They even praise that they hire like every 100 person who applies, and they are very motivated to find the bugs in your software. But there are a lot of shortcomings when you think about that. So the one I did research, they focus on the mobile apps and the web apps, which is very easy to test for the major of the QA people. So what about other types of testing, like embedded systems, which Qt is very, very strong in this area. They also focus really on the speed, on the huge number of testers, but they don't mention much about the quality and the need for the deep product knowledge that the person who starts testing should for sure have. And there is also a risk of confidentiality of leaking stuffs, of leaking prototypes, some ideas. So now when the market is very competitive, that's a really high risk if you give your product very early to a lot of unknown people to you. And of course, the topic that can we think about is also about how we can get the code coverage of the executed test. Is it possible to measure that in a such distributed testing environment and with different users that are testing our product? So when we compare in-house QA team and the crowdsourced QA team, so are those exclusive? So so then we don't need in-house QA at all? I mean, the idea is that they shouldn't challenge the in-house QA experts. Right? They should still feel safe about their jobs because we should hire only do crowdsourced testing during those really crunch times. Like, for example, when we work in the QA tools, when we have a release, everyone not in our department is doing testing, right? And the crunch times are very hard for the QA team, but also for the entire team. So how about only during this time we can get to the crowdsourced testing? And it will also allow us to take care of our in-house QA experts, right? So allocate those resources more efficient way, avoid repetitive tasks they don't like, and they will burn out and they will leave the company. So how about give them different tasks like exploratory testing, which more knowledge is required than just follow a test script. What is the biggest difference is basically time which is used for the testing, right? So when we talk about crowdsourced testing, it's really time measured in hours and a few days, comparing to weeks when you think about traditional in-house testing. You can also take care of the different time zones when you have testers all over the world and they can test 24 hours all weeks comparing to 9 to 5 testing. There is also a bit different motivation, so you usually pay people by hour or monthly salary. Those testers are very often paid by the bugs they found, which actually can motivate them to find easy bugs that everyone will find and not to try to do like hard scenario when a lot of time needs to be invested. They will just go for quick, easy wins. So some platforms are basically saying, okay, we no longer pay per bug, we'll pay per hour, per time used, which is more efficient. So we use this platform for the crowdsourced testing, and this platform should be additional to our testing process that is used in our organization. So it's perfect if you have a single test management tool that we can manage both in-house and crowdsourced testing. The companies that offer crowdsourced QA, they really try to employ the real users, but more QA-minded, and with real devices. When we talk, for example, about mobile testing, with different locations, different backgrounds, different ways of using our tools to give us really meaningful feedback. And this online platform is the way where we share our tests, we share our application, and then the results are gathered there, and we can manage them in-house. You may also think about, isn't beta testing kind of similar to crowdsourced testing? In some way it is, because in both beta testing and the crowdsourced QA testing, you give the testers the real products to use in the real world before you release. And you also will get, for both those types of tests, you will get feedback how the product is performing across the larger spectrum of different individuals, rather your own QA people who knows the product for ages and really know how to use that product. But there is much more differences between beta testing and the crowdsourced testing. So first one is who is performing the tests. In the crowdsourced testing, those tests are performed by the QA-minded professionals in the QA lab, right? And in the beta testing, you are basically trying to give your software to the target people who use that software, your potential customers, right? Your customers are not your testers. Also, the difference is what kind of tests can be performed, right? So if you go with the crowdsourced testing, you get a QA checklist, test scripts to perform. When you go to the beta testing, you just give your product and you say, maybe you give some guidance about how to use that product, but there is no test scripts involved. And also, there's a difference between the goals and the feedback you want to get, right? So in the crowdsourced testing, there's a focus on bugs more, but in the beta testing, it's more about what was the experience using the application. Also, the crowdsourced testing can be focused on a certain area only of your application if you want that. And the time spent on testing is really, again, different one, right? So we have in the crowdsourced a few hours really to test, to do a bunch of tests. And in the beta testing, it's more like a few weeks. And also, for beta testing, we really expect our application to be more feature complete and kind of stable state. It's not that hard requirement for the crowdsourced testing. So when you look at different types of tests, you have the alpha testing, you have a crowdsourced test, you can have a crowdsourced testing and beta testing, and I would put that actually in the middle of those two types of the tests. If you look at how it changes, if you go from alpha to beta, and in the middle of alpha is more like lab environment, in the beta is more like a real world for your tests. Alpha can be more white box testing, and crowdsourced testing for sure, and beta testing is more black box ones. Once you do more in-house, when you do beta, you do more external. And for the alpha testing, it's like QA team or dev team even involved for the beta is the real users that will try to test your software. So we talk about speed, right, of tests. So, but also automating the tests will give you speed of your executing the tests. If your tests are well automated, you can run them and get the results over the night. So it's also very, very fast. But that's the only similarities. There's more differences, right? So with the automation, you have a lot of precision and the speed at the same time, at the execution time. You don't have any creativity and a vision of the humans. You know, the test case, poorly designed test case can pass, and basically the UI looks incorrect because the test wasn't good enough. And also, but the test automation requires some level of the proficiency in programming. Crowdsourced testing doesn't require any programming skills. And also there's a difference in the initial costs. For automated, you invest a lot at the beginning to get a tool, to get people trained to use the tool, to write your test, design the whole framework. That really is a lot of effort. And at some point, you may see results if you make a right decision. In the crowdsourced testing, there's no investment, but every time you run your test very fast, you need to pay for the testers. But you get the same time, hopefully, for the test to be finished. Okay, so now we can take a look about more about the code coverage, and then we'll see how we can combine that. So when you think about coverage, it's actually the analysis method, and we try to measure the percentage of code statement, functions, decisions, conditions. It really depends on what you want to measure, and how many statements, etc., was executed when we run given test. And the code coverage, we don't discuss about how test case was run, right? It can be run automatically, like a unit test. It can be done manually by other tools, right? So for the point of the code coverage, how you run the test doesn't matter. And you measure this code coverage data using a tool which basically can instrument the application source code, and this tool will add some instructions inside the source code of your application to be able to trace how your application is executed and what code is executed when you run the application. When you run your test cases, when you run your test against the compiled instrumented application, the coverage reporting is available. And basically, the code coverage is not the answer to all the problems with the quality, but will just tell you the effectiveness of your test cases. So you may see how much of the application in the end is tested by your different kind of tests. And there are different types of code coverage levels. So, and which type, it really depends sometimes on the industry that you are working with. Like there are other requirements for safety critical systems like airplane, like in the aviation, in the automotive railways, they have all requirements how you should measure. But a good idea is to maybe start with something simple, like just let's measure the function coverage of your test. So then you can say how many functions, among all my functions, how many functions were executed, and then you have a metrics for that. You can go with a line coverage. We will basically measure how many lines of your code comparing to all the lines of your code are executed, right? But the line coverage is very easy to cheat. You can just refactor your code, and then you have higher coverage, but the code will do the same. So for that is statement block coverage is more advanced when you don't care about the lines, because at the end the lines are not important, because it depends, you can basically code different ways. So the statement block coverage will try to count all the statements in the source code, and we basically count which of them were executed, which weren't, and you get the percentage at the end. And now we go to more advanced ones, like decision or branch coverage. So now we don't only look at the statement, but we look at all the decisions, like if statements or loops that are done. Whenever there's a decision, you need to check, okay, during my test case, did I try both branches? And then you will also combine this decision branch coverage is combined with the statement coverage, and you get the idea of how much you've tested. And then there are more and more advanced. So you can also look at the conditions, which, let's say you have an if statement and there's a lot of conditions. So now we not only look about the final decision that your code will go, but you also look at those conditions inside of these decisions, and you can check if those conditions are, for example, true or false, each of them. And with the one that is extremely higher to achieve 100% is the multiple condition coverage. So basically, if you have like if statement with just A or B or C, you need to compare like basically 8 combinations in your code. Sometimes, maybe not the 8, because full condition is not always evaluated if the answer, the true or false, is known before. You don't need to evaluate everything, so it's kind of lazy approach. But this one is the hardest to achieve. And the one that is really required by some authorities for the, let's say, pharmacy and aviations or this safety critical, basically they ask you to measure the modified condition decision coverage. So we still look at all the combinations of every decision in your software you need to make, but we only think about those conditions, those combinations of conditions that at the end they influence the final decision. So it's much less combinations that need to be checked comparing to this multiple condition coverage. So now that we know more maybe about code coverage, is there a way that you can use code coverage with the crowdsourced testing? So basically, we have black box testing, which is done during the crowdsourced testing most of the time, and how we can combine that with the code coverage. So are there any platforms that support collecting information about generated code? Because after you run the test case, you need to provide the report which code was executed. And so what coverage tool you can use that can be used in this scenario? So the one that I will use today is Squish Coco, which is basically which runs for every platforms and compilers like Linux, Windows, RTOS, and others, and supporting different IDEs as well, like Visual Studio, that can be integrated. And at this point, it supports C, C++, C#, and System C, TCL, and QML. So this code that we can basically instrument, and when we run it, you can get the coverage data. Okay, so when you look at different coverage tools, how they approach the problem of measuring the coverage, there are two ways. Like Coco, for example, operates on the source code of the application, so you need to first instrument the source code using the coverage scanner, the tool, which is part of the Coco. There are also some tools that do not require to have access to the source code, and they will operate on the compiled binary, and they will try to take a look into that, into the memory, and see what is executed. So if Coco is basically requiring to have access to the source code of the application, it means that your building process should slightly be modified if you want to measure code coverage. So the Coco must be integrated into the compilation process. So what Coco will do, it has a tool called coverage scanner, which will just take the input code and it will put some counters into multiple places in the code. And in which places this is inserted, it really depends. Do you want to measure statements, conditions, functions? So that's really influences how your code is instrumented. And then, so we have this instrumented code, right, which is modified. And then the idea is that this code is compiled using your original compiler, right? So we are not trying to replace the compiler. And whenever then you have this instrumented binary, and then whenever you run your binary, those counters are incremented, and later on the execution report is generated from this execution. There are some impact that the instrumenting code may have on your application. So for example, the instrumented application can be 60 to 90% larger. It can also run a bit slower, from 10 to 30%. Of course, those numbers really depend on the application and on what type of coverage levels you want to measure. But there is some impact. But the idea of, so the good instrumentation is when the behavior of the application is not changed, because that would be very strange. If we modify the source code, now application works differently. So you are then testing different version of the application, right? But at the end, you ship to the customers the original application without instrumentation. And of course, the instrumentation should not introduce compilation errors. That's basically what the maintenance, the support is working very hard when somebody is complaining that after instrumenting, my application is not compiling. But of course, they need to prove that it was compiling successfully before. And that then we need to fix maybe the way we put our counters, maybe they use some structures from C++ that we didn't think of, but or works incorrectly, we need to fix that in the Coco. So looking into the instrumenting the C++ code, how it works. So first we need to find which compiler to emulate, right? And then we actually, so if you look at the bottom of the screen, we have a source code CPP, for example, and then we call the C++ preprocessor because we want to instrument already preprocessed code. And then you see the instrumenting is something that the coverage scanner does. So it creates a temporary source file, and then using the original compiler, the binary is, the source code is compiled, and you have the object files which are later on linked to your final application. So what then are the products of such compilation of the instrumented code? So we have, of course, the compiled binary that should work the same way like the not instrumented binary. And whenever you run this application, the execution report is created. This file that we call CS.exe, which contains information about what code was executed when you run this test. And also, the second file that is created is called instrumentation database, CSMS file. And this file can be opened in the coverage browser. This file also contains the source code of the application. So you can take a look at and analyze what code was executed. And then you can, this will be your database, and you can basically load different execution reports of this code to this instrumentation database. What is for so it's a Qt conference, so how does it look for the Qt application? Basically, you have some choices. You can use some additional command line parameters to qmake or make. And what I will do, I defined a new scope called code coverage in the qmake project file that whenever I run qmake with this scope, I will get code with code coverage. And we don't want to measure the coverage of everything. Like, for example, we shouldn't measure the coverage of the Qt library itself, right? We don't care about how much library was executed, right? This will actually lower our numbers at the end. It will be very, very low. So we need to exclude that. There are some switches you can do. You can also exclude some code that is generated by the Qt tools, by the UIC, QRC, and the mock. We don't want them. We just want our application. We don't want to have a pure Qt stuff in our measurement database. Okay, so now let's take a look. So here I have a very simple example of the text edit. And now I can show you the project file. And here what is important, at the top you have a code coverage scope. So what we actually are just saying, those coverage options are to basically enable to tell our tool what kind of coverage you want to have. Should we also get the function profiling and all the options for our tool. Later on, here we exclude the Qt library, right? We don't want that, and we exclude the QRC files. We don't care about them as well. We also changed a compiler here to our own. So not our own. This is our own wrapper, right? So and this compiler will also know which is original one. So at the end, it will call this one. Actually, all of them is the same program in the end. It's a coverage scanner. It will know how it was called. Okay, so we have this project file modified. Let's call it qmake with this code coverage. So now make file should be created. Now let's build your application. Okay. And now you see what was created. So we have our binary text edit, right? And we have our CSMS file, right? So let's open the coverage browser, right? And here we have this CMS file. So basically, here you can see different types of coverage levels you can measure. So we can have like a statement, for example, and you can see that, for example, at the bottom here, you can see that this is our instrumentation point. So we don't look at every line. We have just various points we need to reach to say that, for example, if you have a statement, you don't need to verify that you are in the middle of the statement or entire block. If you reach the end of the block, you know that the whole statement was executed. And if we change to the modified condition decision coverage, and let's find some more advanced if statement, we see that, so for sure now we didn't run any code, so we don't have any executions. So we see that what conditions we need to check in our test cases to achieve our condition coverage at the high level. Okay, so let's actually run our application. This is a text edit, probably everybody knows that. Let's just use the application in a normal way, right? I will just bold my text and I will put that here, okay? And let's close the application and don't save. Okay, so now what should be generated is this CS.exe. So whenever we will stop the application, we have the execution report, right? So let's load this execution report. And we can actually give it a name, the test case name. So we just, let's say we call it header. And then we can say, okay, our test case passed, everything was working fine, and we can import the execution. And now we have a lot of colors here. So we see, for example, that our test case already, we achieved 28% of MCDC coverage, and for the statement, it's even higher, 31%. Now we can go to the line that I showed you before. This code was executed, right? And let's go to this line here with the statement. So orange is partially executed, red not executed. But if we go to this line for something, right here, you can see that we actually didn't even went here. This code wasn't executed, but this one was executed by this test case, etc. But this if statement was only partially executed. We only went to the true. We didn't verify false at all in our test case. Okay, so that's basically really basics of the code coverage. There are some additional things we can discuss. For example, we can analyze that only we hit a given instrumentation point, or we can actually count how many times we hit this instrumentation point. And this count mode is default. So we can also say to say that our instrumentation point was covered, we need to hit this point at least 5 times by different tests. And only then we say, okay, this was covered. One test is not enough. So yeah, how does it look? In the coverage browser, you see we have a coverage level. And when we change that to 2, of course, now we get 0. Everything was executed only once, because we just have one test case. So let's go to 1. So what kind of tests, so having seen how code coverage works at a glance, what kind of tests we can actually do when we want to go with the crowd testing. Of course, we can do manual black box tests. The second option is manual black box test plus. We'll get to that, and maybe manual white box testing. So if we go with manual black box testing, we actually, to the crowd, we need to provide only the binaries, so nothing different, just different binary, which is instrumented. We do not provide the CMS file with the source code, right? There is no need for that. And then for every test case, the person needs to stop the application and get this execution report. And then they need to use the platform and basically give the test case status, pass, fail, give the test case name and any additional comments, and attach this CS.exe file. And also, what is interesting that the CS.exe file can actually prove that the test case was executed. So somebody cannot just say test case pass, but now we prove that, okay, actually run the application, went through this, through my test script, this is my execution report, right? So we'll be sure that test case was executed, not just reported. But as I said, if we don't want to mix up coverage from different tests, we need to always think about restarting the application so we get the execution report just for our test case. A kind of alternative approach would be, what if we will give the testers a way to measure coverage by themselves? But we don't want to give them the source code of the application. So there is a way you can actually strip down the CS.ms file to don't contain any source code, and then but the person can still load the execution report and then can see the numbers and try to increase those numbers. But the rest is the same. After stopping the application, the execution report is created, so nothing different. An extreme approach would be to actually give the person the CS.ms file and all the tools to be able to, and actually give them the task to achieve the highest coverage level possible. So maybe no test script, maybe more exploratory testing. Then you can load your the tool, and you can see, okay, this area of the code is not covered by my test case. So maybe here's the idea for the new test case, so it's very easy to add new tests as well. So, of course, what is out of scope of crowdsourced testing? So the unit tests are basically the most natural way of measuring code coverage by far by many users. Of course, the automated API tests, automated GUI tests, all of them are out of the scope for the crowdsourced testing. We don't need that. With the code coverage, you can also measure some, you can do some profiling. So for example, you can measure the functions and measure the time spent in total in given function. You can measure how many times given function was called. You can get some mean values for that, and later on you can compare on the huge number of executions, you can compare some data and maybe see how it differs in the different product versions or different executions, and you may have a lot of data to analyze after running such a test. Another way is, once you have all this data from the code coverage, you can actually get information about which tests are good in gaining coverage and which tests are very poor. And then you can actually calculate the execution order, the best execution order of your tests. So you will run the tests with the highest, which gives you the highest coverage first, and only at the end, the worst test cases will only gives you very small coverage. And you may also find the tests which actually don't give you any coverage, so they are totally redundant. So you can remove that from your unit test, from your test that you execute, if they don't give any new coverage in the way you measure the coverage yourself. This optimized execution order is very good if you have a limited time to run your test cases and you really want to be smart about which one you start with. Okay, so now let's go back to our application and let's run it again. So this time we'll write some text, right? And we'll go with underline. Okay, this will be our test case for the text edit. And you can see that the coverage browser is already jumping. It's excited that there is a new report, right? So, and we can give it a name, underline. And this one also passed, everything was fine. So we can add the results, and now we see we have 2 test cases. Okay, so that is one. We can also analyze, all of them separately. So it's really up to you. Let's run the 3rd test case. This time I will type Tom, and I will do undo, and I will just close my application. Again, we have a new coverage report, and let's call it undo. Let's give it status passed, next, and import and delete. We have 3 test cases, right? Let's try to calculate the optimized execution order for them. And what you actually see here, that the last test case did not run any new code, right? So all the coverage we got was for the header test case and underline test case. The undo test case is basically was from our point of view not needed at all. So let's finally other thing that once you have a lot of tests, some of them will fail, right? And having the code coverage data, you can actually try to use the tool to find the place where there is a failure in your test case, in your application. So assuming you have a lot of tests that passed, some tests that fail, right? We give that to the coverage tool, and it will try to, using some iterative process, it will try to find the place where which was covered by the past test cases, and then we look at the coverage of the failed test case. We try to guess where was the bug in our application. Okay, so let's run our text edit application again, and let's say we would like to type some text, and export that to the PDF. And let's say there was a bug, it didn't work. Okay. Okay. So this will be our last test case. This one will be failed, and we'll say this was a PDF export, which actually failed. Okay, we import delete that. Now we have 3 past test cases. 1 is failed, and now we can actually go with a view bug location, compute. Compute here. And then you see here are guesses where the bug is. And if you go with the first guess, you actually see that this is the place where Coco thinks the bug is. And if you look at the function name, it's file print PDF. Yeah, so try to guess, okay, for the person who debugs the test, that would be also the first guess. So it's not a magic, but with some more advanced code, that can be a help for the user. So let's go back to the crowdsourced QA, right? So now we know more about code coverage. So if we would like to incorporate that in our crowdsourced testing, of course, we must change the way our application is built, change the process. We should have 2 processes, one for production version, one for the instrumentation version. Should be some changes in the test procedure for the testers, as I mentioned, to restart the application every time, and also to attach the execution report to the test management system, so in-house persons, developers can analyze the data from the code coverage. And also the way we analyze the results will change, right? So we can get a lot of data, we can get idea for the new test cases, we can find redundant tests, we can remove the tests that are really not needed anymore. We can analyze the profiling data. So there is a lot of things we can do by having those data about the code coverage. Finally, we can also generate different reports, right? So it's to some other standard formats for the code coverage, like MI-XML report, Cobertura XML report. Those are like a standard used by SonarQube, or you may find those in Jenkins or other CI solutions that that you can analyze later on. Okay, so thank you very much for listening to this talk. Yeah, let me know if you have any questions regarding code coverage or the QA source testing.
There's also a microphone somewhere. Microphone's there. So as an engineer, I'm consuming probably also what comes out of these tests, right? I mean, like, the bugs need to be fixed at the end of the test. So you showed like the coverage, like where the user was. Though maybe I want to reproduce this locally as an engineer, do I also in these reports get certain kinds of kind of a replay or something like that, or where the user clicked or something like that, or maybe a backtrace, maybe through function profiling? Like how am I as a developer consuming these tests in the end? I mean, like, the result of this was maybe, okay, your code is covered by X%, but in order to fix it, can I also leverage the execution report or the run report?
I mean, the report will contain only information about which code was executed by the given test case, right? So you can compare that with other test cases to have a delta. Maybe that will help, but there is no information about what was clicked in the application, what input data was. That is something we need to get from the test case description. But that's actually a good idea for a feature as well.
Yeah, I'm just thinking as a developer, right? As a developer, I think like, okay, so many people test for me, let's make use of that, right? When fixing a bug. Another question I would have is like on mobile applications, you get somewhat like one of those files and they need to be sent to a server. Like, is there maybe a way to kind of have a button inside the application to automatically send the run report, maybe even compiled into the application? I know it's hard because there's so many framework languages and so on, but I just imagine users or the test users running around with their mobile phones and then, okay, I found a bug, and now what? I mean, like, are they going home, putting their phone to a computer, downloading the files? Is there something like this planned, or?
I mean, there is an API that, for example, the unit tests are using, right? When you run more automated tests, there is, of course, no need to restart the application, right? There is a API you can tell, okay, this is the new test case now. And so then we have a send, so now the reports are saved without restarting the application, right? So that's one ways. For some devices like microcontrollers, right? So it's not maybe the use case for the crowdsourced testing, but for the microcontrollers, there is no place to save the execution file, right? So this can be streamed directly to different computer using some API again, right? So this actually can work for release from this very small microcontrollers to really desktop applications with a lot of space.
Right, that's nice. So if there's no more questions from the audience, there's a question? No? Then I'll thank Tomasz once again for for his talk and also the answers. And the next talk will be here in a few minutes. And this will be also from the Qt company, and it will be about Qt Design Studio. So yeah, if you're interested in this, stay here and have a lots of fun at the rest of the conference. Thanks.